Hi, welcome to my talk on Road to Zero Lint Failures. I'm Chris Ng, and I'm a senior staff software engineer at LinkedIn. Let's get through it. First of all, we'll go through why lint rules, why are they important, code quality at scale, what are the challenges when dealing with code quality at scale, and the techniques that we employed to fix code quality at scale, which is the road to zero lint failures. Finally, we'll discuss any results that we got from this journey and next steps. So why lint rules? We used to have a saying that if it's not in the docs, then it's not a real thing. Um, Lint rules help automate a lot of these inconsistencies and errors that you want to enforce in your code base. Popular lint tooling includes ESLint, StyleLint, and other specific linting technologies for whatever framework that you use. So lint rules, the best part about lint rules is that you can automate them. It can run during development, during pre-commit, and during pre-merge, and any part during the software development lifecycle. So what this means is it catches all of your errors and inconsistencies right as the engineer is working on the code base, not when it's close to shipping to production or even in the PR state. It's right when they're working on their IDE, as you can see here. We use Prettier for our tooling for any kind of styling and formatting inconsistencies. So this runs every time you commit something to the code base. This way, there's no more arguments about formatting or any kind of like, hey, can you add an extra space here, an extra line break over here? That's all kind of resolved by our tooling. So it's more than just styling issues, right? Lint rules help enforce coding standards, make your development a lot more streamlined because you understand where everything is placed. And it reduces a lot of bike shedding, which is kind of like discussion among PR reviews where it's someone wants to just like, hey, you should follow this pattern, but the other person doesn't agree. Lint rules enforces a consistent standard, which prevents bugs because someone else have thought through all the edge cases and maybe identified a pattern where this doesn't make sense. It also helps with maintenance because when you're dealing with like any kind of migrations or any refactoring even, having a more predictable code base makes it a lot easier to migrate your code base. So here's an example of a lint rule that's very interesting to me. It's called a no unsafe optional chaining. I believe it's generally available in ESLint, maybe version 7 or something like that. Um, Essentially, you have this paging object, and you're kind of like updating this paging object within your class, something like this function. So it seems kind of nice, right? Like it seems kind of like you're doing optional chaining to kind of guard against incorrect data being sent down to you. Hopefully it works out. However, the lint rule catches that you're doing some unsafe operation that could result in not a number. So what will happen here is that if your data.paging.start, the data that you received was actually undefined, then when adding it to the existing object, let's say 10, you will result in a not a number. This is kind of like a very weird edge case, can happen to anyone working on a large scale application, especially if you're not quite sure who's sending down the data to you. And of course, if you're in a crunch, in a timeline crunch, you might make this very easy mistake. Lint rules help us enforce catching all of these bugs before it reaches production or even like your test suite, right? Um, I like to call it expanding the well-lit path. So we all have like the default case where the framework works really well, your existing patterns work really well. But if you need to do something outside of this default case, they might be a little bit harder. Lint rules expands the well-lit path, so it's easier to do all of these things. So you might think, hey, let's add all the lint rules, right? Like it's there seems to be like no downside. Let's just add all of it and have like complete awesome code base. Unfortunately, when you're dealing with code quality at scale, it's not quite so simple. Um, for context, our application that we ran this project on is over 8 years old. In 2015, for example, React was just version 0.13. We have over 24,000 files um, and over 100K commits throughout the 8 years. Our code base has been growing like 21% year over year, which is crazy. Over a million lines of code. There's about 6 to 7 PRs that get merged per day from humans, not any kind of like automated dependent bot or anything like that. Um, and we have over 800 unique engineers with at least 5 commits. So they're not just like one line changes. They're somewhat familiar with the code base. So with so many, so the problem that we were facing was that there were so many lint failures in the application because of the lifetime of the app, right? It's been 8 years. Stuff has been upgraded, migrated, refactored, and we actually ended up topping 7,000 errors in the application, which is crazy. So ideally, the way to fix this is that you leave the campsite better than you found it. So every time you touch a file, you fix all the lint failures there, and then you commit that. And over time, you'll end up in a better state than 7,000 errors. Um, but what if you came to a campsite and it already looks bad like this? What we've seen is that kind of like the first thing that we've tried is blocking commits. If there's a lint failure in your change file, you can't commit that file, and so it forces engineers to resolve the lint failures. We've also tried setting limits. So like let's say every like existing lint failures is okay, but the new ones are not as okay, or have kind of a platform review system, which is kind of like a human curated list of people who would go through PRs and say like, hey, you need to fix this, you need to do this. Some of them work, but most of them didn't really work, right? Like a lot of these did not scale very well. Blocking commits is the one that really worked the best, but we've seen a lot of cases where, let's say you need to do something really fast, and there's so much lint failures in your file, and you don't really have the time to resolve it. So you kind of just squeeze around it and ship it. We've even seen engineers avoiding files that are extremely dirty with so many lint failures. So that's obviously something not we don't want, especially overriding, which could introduce even worse issues because of the linter not catching it. Um, so the first thing we did was stopping the bleeding, right? We instituted a lint proposal system which democratized the process, which means anyone can propose a lint rule or a change to a lint rule, an existing lint rule. However, we kind of wanted some ownership around this, so there was also a task force who reviewed these proposals and basically gave it a yes or no. This way, there's some accountability. Task force was tasked with making the code quality better, and then existing lint failures are there to be resolved by the task force as well through the help of the community. So yeah, this kind of went really well actually. We got a lot of lint rules proposed and added to the code base and made the code base a lot better and more maintained. Um, the big sticking point here is that all existing failures must be resolved before you uh, turn on a lint rule. This is kind of like a way to make it more sustainable and ensure that we don't keep adding new lint rules to the code base where the 7,000 number just becomes 8,000, 9,000, 10,000, right? And never gets resolved. Um, as an author, you might say, like, what if there's 1,000 errors that I enable with my lint rule? I can't fix that. I don't even know the code base that well to fix these existing errors. I don't really have time to do this. I want to go on vacation. What if I break something and cause a production issue? Um, these are kind of like there are existing failures, even that 7,000 number to the files I'm cleaning up. So maybe like you're trying to turn on a lint rule with 5 errors, but one of those files had 100 errors existing. This is kind of like a problem that we've been trying to face, right? Like this 7,000 number is quite a challenge, even to adding new lint rules. So what we found out was that not all problems are solved through engineering. Being human helps. These same issues are faced by engineers working on files that they own, right? So when they're changing something on the file with 100 lint errors, it's the same kind of issues. Like they might have inherited the file. They are not quite sure if fixing these lint failures would break the production app. So being a human helps, and trying to understand how to incentivize engineers to fix these issues and make it more risk-free. So that's the road to zero lint failures. Resolving those 7,000 lint failures in a more risk-free way, or at least like less risk. So it comes down to incentives. Incentives is kind of what drives everyone to do something in a large company, right? So as I mentioned at the beginning, we tried to make sure that each file has an accountable team that owns it. We helped engineers provide a business case for why they should resolve these lint failures. Namely, it makes it easier to ship something new, and also kind of like prevents more serious production issues. We also gave like insights for engineers to identify which areas are easy to fix and which ones are a little bit harder. So the whole kind of incentive culture, right, is providing technical support to the day-to-day engineers working on resolving these lint failures. Make it so easy to identify these lint failures and provide those engineers with recognition, shout-outs, and visibility. Everyone kind of wants to be thanked for the hard work that they put in, and these kind of like glue work is often forgotten, right? And I think by shining a light to these engineers working on these initiatives, we've kind of developed a culture of more of accountability and like even gamification. So the tooling that we provided identified the errors, identified the owners, and it's up to date and super simple. So you don't have to run some random command line tool or something like that. We had a single owner per file, which was a separate effort to what we were already doing, which made it a lot easier. So we can identify that each file with a lint failure is owned by a particular team. So this is kind of like the MVP version. We didn't even put any CSS. It was a HTML table and like basic tags. Everything is sample data, obviously, but we broke it down per team and the total number of lint failures. It ran on someone's virtual machine every night via cron job. Sometimes it would break and we would have to fix it, but all in all, it worked great, right? This is kind of like a more in-depth view of a team, or actually this one is a lint rule no unused vars. It showed you every kind of file who has this lint failure. So if you're doing a max fix, for example, you can find out all the files right away. For the cron job, we use a open source tool called Checkup, which was also developed within LinkedIn. It's kind of like a task runner, which helps us kind of identify all the failures from ESLint. It can also kind of like hook into Silent or any kind of other tooling that you have. It's mostly a task runner. So this is kind of like a sample result from Checkup, where it will gather your for this one, it's like the ESLint failures and warnings and disables and a particular lint rule if you're interested in that. And it creates a Sarif file which has all the data. Sarif file is kind of like this standard format, which VS Code can actually read and like point you to the particular file. However, it's kind of hard to use, right? Like you don't really want to run a command line tool to find something to fix. So we then consume that Sarif file and created a UI around it. So we run this every night and then output it to this UI. And we also updated our UI because it kept going down. Someone kept turning off accidentally the VM, and it was so heavily used by the team that it was worth migrating it to the Docusaurus platform. So to help identify these issues, we've also done a weekly scorecard broken down per team. Green is if you have zero lint failures for your entire team, or you've decreased your lint failures week over week, even by one. That's a good thing. Yellow is if nothing happened. It's zero week over week increase or decrease in lint failures, and red if there's an increase in your lint failures week over week. This is kind of like a sample scorecard that we would send out. We would also identify maybe 2 to 3 engineers who fix big issues and give them a shout out and a link to their PR and kind of like an actual like engineer's kind of guide to what they actually did, rather than kind of just platitude. It was a manual email for us. I even manually identified 2 to 3 engineers going through the PRs, but it worked out for us, right? The part that was actually kind of difficult was the last mile. It was very, very hard to get the last 20%. The first 80% was kind of very organic, grassroots kind of style. But getting down to zero was very hard. But you might ask, does it really matter? Like, why do we need to get down to zero if we've decreased it by 80%? Well, as you can see, the last mile took maybe half the time that it took us to get down to zero. There's a lot of reasons for that. Some of them are trying to convince teams, and some of them are like more bandwidth issues. I also went on parental leave in the middle of this, so there was a part of time where I was out. But essentially, I really do think the last mile matters because imagine kind of like working on this file, right? Like maybe this is the last file that was not fixed in the code base. But when you look at this file, there's so many red squiggly marks. It kind of like is intimidating and you don't really want to touch it. So you might want to just rewrite it completely and maybe introduce more bugs, cause issues, or let's say you have to do a migration. It's a forced migration to a new version of the framework and you have to touch the file. And you get this sudden surprise of like extra work in the middle of it. Compare that to something like this file where It's all clean, ready to go, ready to be um, added, changed. It's a lot more kind of like consumable as an engineer. So as a summary, what we did was have no new errors in the code base. That's having a pre-commit hook and an CI that runs for change files where any new errors we report. And if you introduce a new lint rule, you can't have it introducing new errors to the code base. A single owner per file, so we know exactly which team to follow up on, or even to help if they don't have any time and expertise. We would we would get our hands dirty and get there and fix the lint failure. Because if we're not gonna fix it, if we're not willing to fix it, right, like the team might not be willing to fix it either. We use a cron job every night to run checkup and get the report. We have a very easy dashboard identifying the issues, so engineers don't really need to run any command line tools to find the issues for their team. And we have a weekly scorecard to make sure every team is accountable. And in part of this scorecard, we give a lot of recognition for particular fixes rather than general team recognition. And yeah, like I said, get your hands dirty. You lead by example and make sure you fix your a lot of lint failures for the team. So what did we see at the end of this? The lesson we learned was that focusing on individual developer experience was really, really great. Even if it's like not so easy to get the overall report for the entire like application, the individual is where you want to identify it because they're the ones who's fixing the lint failures. They're the ones who's doing the work. So they should get the best experience. Personal shout outs, for example, for the individual, and no regressions, right? So at the end of it, we remove almost 6,000 lint failures. The other numbers were even like completely deleted. There were some files that was not used, so I didn't count that as lint failures removed. Those files were just deleted. It took a little over a year to complete, and we had 55 engineers who helped with this effort. And we saw our code quality net satisfaction score go up by 30% since with all the linting initiatives that we ran. We had over 80 lint changes in the application going through the process, the proposal process, and 45 contributors who've either created, updated, or deleted lint rules. So back in 2017, right, we had a saying, if it's not in docs, it's not a real thing. Now, if it's not a lint rule, then it's not a real thing because it's so hard to make everyone read the docs, make sure every last mile, every person reads the docs, and then enforce it at the same time. This is what computers are good for, this is what lint rules are good for. Thank you, and if you have any questions, feel free to either DM me. I'm at Chris RNG pretty much everywhere. And yeah, thanks so much.